Hello viewers, I am Kausalya. Today we are going to solve example problems in chapter 10. Example 1 is prove that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. So here we are having two concentric circles. What do you mean by concentric circles? Circles with the same center but different radius. Right. So here we are having two circles, right, with the center O, and they are at different radius. And the chord of the larger circle, okay, this is the smaller circle and this is your larger circle. Chord is nothing but it is the line, okay, that joins two points on a circle. That is known as chord. So the chord of the larger circle. So in this diagram, AB is the chord. Okay, this chord touches the smaller circle. Right. So we are assuming let the chord AB touches the smaller circle at point P. Right, is bisected at the point of contact. What do you mean by bisected? It is equally divided into two. Right. For example, if we are having the length of the chord AB as 10 centimeters, then AP is 5 centimeter and PB is 5 centimeter. Okay, the chord is bisected. That is the reason it is equally divided into two parts. Right. So, you see here C1 and C2 are the two concentric circles with center O, and AB is the chord. Right. And OP is the radius of the circle. So, here AB is a tangent to the circle C1 at the point P. It is obvious, right? So, AB is a chord according to the circle C2. But AB is a tangent. When you just remove C2, what is AB? AB is a tangent to the circle, inner circle C1. Right. So, by tangent radius theorem, OP is perpendicular to AB. It is clear, right? OB, that is OP is, it is perpendicular to AB. Because AB is a tangent and OP is a radius. So therefore, you see here, this is what I had written, right? By tangent radius theorem, OP is perpendicular to AB. Now, AB is the chord of the circle C2 and OP is perpendicular to AB. Yeah. That is, whenever we consider only circle C1, AB is a tangent. But when you consider the circle C2, AB is a chord for circle C2 and this OP is perpendicular to AB. Right. So, therefore, here we are concluding that OP is the bisector of the chord AB. Right. And AP is equal to PB here. You see. This OP is perpendicular to the chord AB. So that is the reason here we can tell AP is equal to PB. Right. So this problem gets over here. We will proceed with the next one. So problem number 2. Two tangents TP and TQ are drawn to a circle with center O from an external point T. Prove that angle PTQ is equal to 2 times of angle OPQ. So here we are having a circle with center O. So draw a circle with the center O and we are having two tangents, right, from an external point T. So here T is the external point. From this point we have drawn two tangents to the circle, right. So here we have to prove that angle PTQ, that is this angle, right, is equal to 2 times of OPQ. Right. So here we have drawn this line, and there is a center. Right. So now just we have to join this PQ and join this OP. Right. So this angle OPQ. Right. So angle T is equal to 2 times of angle P. This is the thing we have to prove. Right. So just write down the things what we have done. Okay, this is the circle with center O and T is the external point and TP and TQ are the tangents, right? So the proof is, you see, TP is equal to TQ. This is based upon our theorem 10.2, right? the lengths of tangents drawn from an external point to the circle are equal. Then the next thing is, you see, here OP is the radius and TP is the tangent. Then OP is perpendicular to TP, right? So just include that point also. OP is perpendicular to TP, right? This is by theorem 10.1. Here I have simply written tangent radius theorem. You can better write, okay, frame the sentences. Then again you look back here, right? So by theorem 10.2, what we have concluded, TP is equal to TQ. So now consider this triangle, right? TPQ. So in triangle TPQ, you see TP is equal to TQ. What does it mean? That is, two sides of the triangle are equal, right? Whenever two sides of the triangle are equal, then we can call the triangle as a isosceles triangle, right? So in isosceles triangle, the main thing is angle opposite to the equal sides are equal. So here you see, this is your triangle TPQ and this side is equal to this side, right? So the next thing is angle opposite to the equal sides are equal. So here this is the side. What is the angle which is opposite to this side? The angle is P, right? And again consider this side. That is, consider only this triangle, okay? Don't consider any other thing. That is T, P and Q. And this side is equal to this side. So angle opposite to this side is P and angle opposite to this side is Q, right? Therefore, angle P will be equal to angle Q, right? So first let's frame these two things. You see, TPQ is an isosceles triangle because two sides are equal and angle opposite to the equal sides are equal. So here the angles are P and Q, right? So the angle should occupy the center part. I hope you people know this concept, right? So even you can write TPQ also. Here also you can write, TPQ and you can write it in reverse, TQP also. It holds the same meaning, right? Now the next thing is, we are going to consider our theorem 1. So in this theorem 1, you see angle OPT is 90 degree because this is the radius and this is the tangent and they are perpendicular to each other. So angle OPT is 90 degrees and angle OPQ, we are assuming it as theta, right? So you see, observe carefully, OPT, okay? This angle OPT is 90 degree and this angle is theta. So what about this angle? What about this angle? The entire angle is 90 and this is this is theta. So here this angle will be 90 minus theta. That is, you see, again I am drawing here, right? And there is like this. The whole angle is 90 degree and this angle is theta, right? So what about this angle? This angle will be 90 minus theta. Am I making clear? And this is your T and this is your P and this is your O, right? So the angle, you see, angle QPT, right? QPT is 90 minus theta. Okay, here QPT is 90 minus theta, and similarly we can write angle PQT is also 90 minus theta, right? Because again when you draw a line, this OQ will be radius and TQ is a tangent and again they will be perpendicular. Again the same concept will lay here. So therefore QPT is 90 minus theta and PQT is also 90 minus theta. So this is what I had written here. Right. Now consider the triangle PQT. Right. This is your triangle PQT. So you see, the summation of angles in a triangle is equal to 180 degrees, right? So here PTQ plus TQP plus QPT is equal to 180. That is, you see, you look at the center, angle T, angle Q and angle P. Angle T, angle Q and angle P is equal to 180 degrees. Sum of angles in a triangle is 180, right? Now, PTQ, I don't know what is the value of PTQ, so I am keeping this as such, right? So, just now we have find out the values of TQP and QPT, right? Both these are 90 minus theta. So just substitute the values, right? And when you add here, what happens? Here P2Q as such, 90 plus 90 is 180, minus theta becomes minus 2 theta, which is equal to 180 here. Now I am moving this entire part to the right hand side. So what happens? Plus 180 becomes minus and minus 2 theta becomes plus. Right. So this plus 180 minus 180 becomes 0 and finally PTQ is equal to 2 into what is theta here? What is theta? Again we have to look back at the diagram, you see. So from this diagram, what is theta? Theta is nothing but OPQ. Right, because this is theta here. So theta is OPQ. Right, so finally we have proved PTQ is equal to 2 times of theta is OPQ. So here it is proved. Right. So problem number 3. Here again PQ is a chord of length 8 centimeter of a circle of radius 5 centimeter. First draw a circle and circle has a radius of 5 centimeter. Right, and PQ is a chord. Chord is nothing but again it is a line that joins 2 points of a circle. Okay, here PQ is a chord and its length is 8 centimeter. The tangents at P and Q intersect at a point T. Okay, the tangents at P and Q, they are intersecting. Okay, they are meeting at a point T. Find the length TP. So we have to find this length. Right. So the thing is, now we have drawn this radius and these 2 tangents and this chord. Right. So to find the value of TP, here we are connecting OT by ourselves. Right. So here the first step is, you see, join OT. Right. Now this OT, right, it intersects the chord PQ at a point R. Right. So because of this, okay, this divides the chord of 8 centimeter equally into 4 centimeters, because here you see this is the line at the middle of the chord. So this 8 centimeter is divided as 4 and 4 here. Therefore, you see PR is equal to RQ, which is equal to 8 by 2, because the total length is 8. So this line divides the chord into 2. So 8 by 2 gives you 4. Right. So now look at this triangle. Okay, POR. We know the value of this side. We know the value of this side. So we are going to find the value of this OR. Right. So what is the rule? How can we use that? You see, when you look at this diagram carefully, okay, this angle is 90 degree. Yes or no? Because they are perpendicular to each other, right? So whenever you are having lines like this angle is 90. Similarly, this will be also 90. Similarly, here also. Okay, whenever you have a perfect L shape, that contributes 90 degrees. Right. So by using Pythagoras theorem, we are going to find the value of OR. Right. So when you apply Pythagoras theorem, we can write it as OP square is equal to PR square plus OR square. Right. So OP is 5 and PR is 4. So just substitute the values. So 5 square is equal to 4 square plus OR square. 5 square is 25 and 4 square is 16. So we need OR square. So just move this 16 to the left hand side. So 25 minus 16 gives you 9. And when you take the square root, the value of OR is equal to 3 centimeters. Right. So now we have find the values of all the sides. That is, the unknown side OR is calculated. Okay. So in this triangle, we know the values of all the sides, right? Again you see in triangle TPO, right? So here just I have drawn the same thing, triangle TPO. Okay, consider this part. So here you see this is OP is radius and TP is tangent. So what about the angle here? So the angle OPT will be equal to 90 degree, right? This is based upon theorem 10.1. That is, tangent at any point on the circle is perpendicular to the radius through the point of contact, right? So here the perpendicular, it is nothing but it denotes that the angle is 90 degree, right? Now we are going to consider other two triangles, right? Because to find the value of TP, we are going by this way. So here we are considering two triangles. One is triangle OPT, right? This bigger one, and another one is OPR, right? So when you consider these two triangles, right, that is OPT and OPR, here this point O is common, that is this angle is common. Do you agree or not? Obviously it is yes. Wait, let me draw these two triangles separately. Right. So here you see we are having the same angle here, right, O. Therefore angle O is common. Just write it, right? Here you see TOP is equal to POR or ROP. Okay, anything is fine. And again both these triangles have 90 degrees, right? So you see here this angle R has 90 degrees and here the angle P has 90. See, here the angle R has 90 degrees and here the angle P has 90 degrees, right? So just make a note of it. So PRO is equal to OPT, again they are 90 degrees, right? So therefore by angle criteria, right, we can tell that these two triangles are similar, right? So while writing, you see that is triangle OPT is similar to triangle OPR, okay, but you should write this in a better way, right? Because only based upon this angle criteria we are going to find the value of the side TP, right? So here the thing is, you see here in these two triangles, right, what is the angle that gives 90 degree? In this triangle it is P and in this triangle it is R. So first write P and R, right? Now the next thing is, what is the common point? Here the common point is O here. So then write O and here also it's be O, right? Then what about the remaining thing? We had write P and O here, R and O here. So in first triangle I am having T and in the second triangle I am having P here, right? Therefore here we are writing T at the front and the same way here in this triangle we are writing P at the front, right? Again I am telling you can write T at the end also, right? Okay, anyway it is fine. Since we need to find PT, I am writing T at the front, right? Even if you write it at the back also, you can write it accordingly. Let me show that also, right? So you see when you write like this, that is angle POT is similar to triangle ROP, right? So when you write the values, how you can write the sides? That is PO by RO is equal to OT by OP and which is equal to TP by RP, right? Anyway, you see we will be having the same things. PO by RO, yeah, it is here. OT by OP, it is here. And TP by PR, it is also here, right? So write accordingly. It's up to you. Fine. Now, that is, it is the easiest way to write the thing. Okay, once you clearly define the triangles, then you can write the sides. So by angle criteria, since these two triangles are similar, these sides will be similar, right? Same. That is, this ratio will hold true. So consider now what is the thing we need? We need to find TP, that is length of the tangent. So here we can select the ratios accordingly, right? So now I have considered TP by PR, which is equal to PO by OR, because the reason is here we know the values of all the things, right? So TP by PR, the TP we need to find, and PR, what is the value of PR? Wait. So here you see the value of PR, it is 4. So write it as 4. And what is OP? Here OP is 5 and OR is 3. So here it is 5 by 3. So the value of TP is, it is 5 by 3. When you move this 4 to the right hand side, this occupies the numerator part. So 5 by 3 into 4, therefore here the value of TP is 20 by 3 centimeter. Right. So this is one way of solving the problem, or else we can use our Pythagoras theorem to find the length of the side TP. So you see, by Pythagoras theorem, so what is the main thing? In which condition we should use Pythagoras theorem? That is, only for right angle triangles we can use Pythagoras theorem. Okay, in a triangle, one angle should be, that is, one value of angle should be 90 degrees. So here in this diagram, we are having two right angle triangles, right? So first we are taking our triangle PRT. That is, we are taking this part, right? So in this PRT, what is the angle? Which one is 90 degree? Angle R is 90 degrees, right? So the side which is opposite to this 90 degree is the hypotenuse. So here hypotenuse is this TP or PT. So you see TP square is equal to TR square plus RP square, right? So here the value of TP, we are taking it as X and TR as Y. Therefore, X square is equal to Y square plus PR is 4, it is 4 square. So when you solve, X square is equal to Y square plus 16. So just for our convenience, I am reframing this expression as X square minus Y square equal to 16. Right, I am moving this Y square to the left hand part. Right, so let this be equation number 1. Okay, not this. Let this be your equation number 1 here. Now, consider the triangle. We are considering OPT. That is this part, okay, OPT. Right, in this OPT, what is the angle that gives 90 degree? This angle, right? This is the angle that contributes 90 degree. So what is the hypotenuse? Automatically, this OT is the hypotenuse side. So just frame the expression, you see, OT square, right? OT square is equal to TP square plus PO square. Right, what is OT? The side OT, you see, TR plus RO. Right, OT is nothing but TR plus RO the whole square. The value of TR is Y and the value of RO is 3. Therefore, Y plus 3 whole square is equal to, and again PT is X and this PO is 5. Right, so this is of the format A plus B whole square. So A square, right, Y square and B square is 9 and 2AB, that is 2 into 3Y, which gives you 6Y, which is equal to X square plus 25, right? So the next thing is I am just rearranging the terms, right? So I am moving this Y square to the right hand side and I am moving this 25 to the left hand side. So what happens? Here this Y square becomes minus, therefore X square minus Y square is equal to, here 9 plus 6y minus 25, right? 9 plus 6y minus 25 is equal to X square minus Y square. So when you solve, 9 minus 25 gives you minus 16, right? So you just see, previously we had framed an expression, right? X square minus Y square is equal to 16. Therefore, just replace this X square minus Y square by 16 here. So when you move this minus 16 to the right hand side, it becomes plus. Therefore, 16 plus 16, which is equal to 32. Therefore, the value of Y is 32 by 6. Right, when you solve, you see 1 2 is 2 and 6 2s are 12. Here 3 2s are 6. So the answer is Y is 16 by 3. But what is y? Y is your length tr. But what we actually need? We need this length tp. So again we are considering our equation 1 here. That is x square minus y square is equal to 16. Right. So y we had just now calculated, it is 16 by 3. Therefore 16 by 3 whole square. Right. So we need only x square, right? So I am moving this part to the right hand side. So 16 plus 16 by 3 whole square. And again I am squaring these numbers. So 16 plus 16 square by 3 square is 9. Right. Since both the numerator term has 16, I am taking this 16 outside. So when you take this outside, the remaining term will be 1 plus 16 by 9. Right. So again when you take LCM, what happens? 1 into 9 is 9. So 9 plus 16 by 9. Right. 9 plus 16 by 9 is 25 by 9 here. And this is your x square part. But I need only x. Right. So we are taking square root of all these terms. So square root of 16 is 4. Square root of 25 is 5. And square root of 9 is 3. So finally 4 into 5 by 3, which is 20 by 3. Right. Therefore here the length of the side TP is equal to x, which is equal to 20 by 3 centimeters. Right. Here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.